Hey, it's OG Math Mosley. Today we're going to continue with some AP statistics topics. So we're going to be talking about standard deviation and variance. We're going to look at how to calculate those and then how we can use those, specifically how to use the standard deviation to determine if there are any outliers. All right, so let's get started. So here is our situation, and we have the following sample of men's heights. We need to find the mean, variance, standard deviation, and then we're going to check for outliers using standard deviation. So we have all of these men's heights. They are already sorted for us. Unfortunately, when dealing with mean, variance, standard deviation, the order of the data doesn't really matter as much as it does for median and like IQR and those types of things. So we have our list of data. Let's look at how many data points we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in this case, we have an n equals 11. That's how many data points we have. So we'll be dividing by 11 to find the mean. And let's calculate our mean. Right? We'll find our x bar. As far as we know, this is just a sample. So we're going to call it x bar instead of mu. It's only 11 people. All right, so add all the numbers up along the top, which was all of our heights, divide by 11, we get a mean of 70.64 inches. We want to include the units on our measure here because it is a measure of height. The units need to keep sticking around with it. All right, so now that we have the mean, we can now calculate or do the steps to calculate the variance. Now this takes a bit of time to do by hand. Luckily, we only have 11 data points to do this with. And what we're going to do is we're going to set up a table to stay organized because that really helps a lot in this situation. Our first column will just be the observations, right? Which, is just x, right? Then we have the difference between the observation and the mean, which we'll say is x minus x bar. Then we have the squared difference of the means. All right, so that will be x minus x bar squared, right? The squared difference. So for example, our first observation was 62. 62 minus 70.64 will give us negative 8.64. In outer space, move this guy over a little bit. So we get negative 8.64, right? Negative 8.64 squared will give us 74.6496. Right? So that's how we're going to calculate each thing. We start with the observation, find the difference between the observation and the mean, and then square that difference, right? And we need all these numbers, right? Well, essentially we need the last row or last column. All right, so now we'll continue this with the rest of our data points. All right, and then as a note, all measurements in inches. All right, so now we've got this great table of values. The one we're really interested in is the squared differences, right? This last column. This is the one that I needed from the beginning. I just had to do all this other work, and it helps me stay organized to do the table. Right, so now I have my squared differences. Right, so I can find the variance using those differences. And so what we do is we add up all of the squared differences and then divide by one less, because this is a sample. If it was a population, we would just divide by the number of observations, but we do one less than the number of observations. So 11 minus 1. Right? And that will give us our variance. Right, so we'll show this calculation here. I'm going to show it with the notation so we can get used to seeing that. So our variance is equal to, right, this is our little notation for variance, is s sub x squared is equal to the sum from 1 to 11. That's because I have 11 observations. X sub I minus x bar squared. This is the sum of all the squared differences. That's what this top part means, divided by 11 minus 1, right? N minus 1, the number of observations minus 1. When we put in all of our data, we end up with 200.5456. It's the sum of the differences. We divide that by 10, and we get 20.05456 inches. So this is our variance. Now to find the standard deviation, it is the square root of the variance. So we've already done this work. Again, I'm going to show you the notation. So I want you guys to be familiar with it. I don't want it to frighten you, so to say. So our standard deviation will be equal to the s sub x, which is equal to the square root of the sum of the differences of the means divided by 11 minus 1. And that is specific to this case. We could just write n minus 1, but we're using our numbers for the bottom there because we can, which is going to be the square root of the number I have here, 20.05456, which is approximately 4.48 inches. That is my standard deviation. So that allows us to say something now, right? So we can make the following statement. So based on this sample of men's heights, their heights typically vary by about 4.48 inches from the mean height of 70.64 inches. So that's a statement we can make based on our standard deviation. All right. So now let's check for outliers. So that means we'll check for a lower and upper bound. So the lower bound, we will say 70.64 minus 2 times 4.48. And that will give us 61.68 inches. Right? So any data point or any heights lower than 61.68 inches would be considered an outlier. For the upper bound, we take that same 70.64 mean and we add 2 standard deviations, 2 times 4.48, and that gets us 79.6 inches. Okay, so any value above or any height greater than 79.6 inches would be considered an outlier on the high end. If we look back at our data, our minimum was 62, our max was 77. So then based on that, we have nothing lower than 61.6, higher than 79.6 inches. So we get no outliers. Okay. All right. And so that is a brief example on how to find our variance and standard deviation, and then how to use that to check for outliers. Again, if you have any questions, please let me know. Other than that, we'll see you next time. Bye.